Alright, so I'm going to do a couple more examples of L'Hopital's rule. Uh, this will be examples 3 and 4. Uh, so if you watched the first video, I read through L'Hopital's rule. Basically what it's saying is if you take A and you plug it in for X and you get 0 over 0, or infinity over infinity, negative infinity over negative infinity, then that's equal to the limit as X goes to A of the derivative of the numerator over the derivative of the denominator. Okay, and this X approaches A, that can be replaced. This can be replaced with X goes to plus or minus infinity, or X approaches A from the right or the left. Alright, so let's take a look at an example. Alright, so we have the limit of x squared over e to the negative x as x approaches negative infinity. Okay. Alright, so let's see what happens when we take the limit as x goes to negative infinity. Well, we're plugging in negative infinity and we're squaring it. Okay, so we're getting big positive numbers. So you can see that the numerator is going to infinity. And then for the denominator, when we plug in really small numbers, okay, well, the negative and the negative, because see, it's like negative 1 million, negative 1 billion, all the way to negative infinity. Well, the negative and the negative make a positive, so the denominator is going to infinity also. So we have infinity over infinity. So we can say that this is equal to the limit as x goes to negative infinity, and we can do the derivative of the numerator over the derivative of the denominator. So that's 2x over, and then derivative of e to the negative x is negative e to the negative x. Alright, so now let's see what happens. Well, the negative infinity, well, you can see that if we put in really big numbers with a negative sign in front of them, this is going to negative infinity, the numerator is. And then for the denominator, well, the negative and the negative, because we're going to negative infinity, that's a positive. So that's going to infinity with a negative. So we have negative infinity over negative infinity. So we'll apply L'Hopital's rule a second time. So that's going to equal the limit as x goes to negative infinity. Derivative of the numerator is 2 over the derivative of the denominator. So that's going to be, there's our negative sign, and that's going to be negative e to the negative x, okay, which equals 2, which equals the limit as x goes to negative infinity of 2 over, and then the negative and the negative make a positive. Alright, so now we have 2 over e to the negative x as x goes to negative infinity. Well, the negative and the negative, that's going to make a positive, so that means this denominator here is getting really big, and the numerator staying at 2. So we have 2 over a really, really big number, so that means the whole fraction is going to 0. Alright, let's take a look at example 4. Alright, so here we have the limit of e to the negative x, e raised to the negative x times square root of x as x goes to infinity. Alright, so as x goes to infinity, well, the square root of x, that's going to infinity. But what's e to the negative x doing? Well, remember, e to the negative x, okay, that can be written as 1 over e to the x. So as x goes to infinity, this whole thing here is going to 0. So we have 0 times infinity. That's an indeterminate form. We can't do that. So let's see if we can rewrite this and get this in one of the forms, either either 0 over 0 or infinity over infinity or negative infinity over negative infinity. Let's see if we can get it to something like this. Well, we know this is equal to the limit as x goes to infinity of square root of x over, and then remember that's over 1, so if we move this down it changes the sign of the exponent, so that's e to the x. Okay, now as x goes to infinity, you can see the numerator's going to infinity, the denominator's going to infinity, so we have infinity over infinity. So now we can use L'Hopital's rule. So we have the limit as x goes to infinity, and then the derivative of square root of x. Okay, do you remember what that is? Well, if we take the square root of x, remember that's the same thing as x to the 1/2. So we use the power rule, so that's 1/2 x to the negative 1/2, which equals 1/2 over x to the positive 1/2, which is 1 over 2 square root of x. Okay, we move this down to the denominator with the 2, and it changes the sign of the exponent. Okay, so the derivative of the numerator is 1 over 2 square root of x, and the derivative of the denominator is just e to the x. Alright, so we have the limit as x goes to infinity, and then, okay, this is over 1, so that's going to be 1 over 2 square root of x times the reciprocal of this, 1 over e to the x. Let me get rid of some of this. Alright, so this is going to be the limit as x goes to infinity of 1 over 2 square root of x times e to the x. Alright, so what's this denominator doing? Well, the denominator is going to infinity. Square root of x is going to infinity, and e to the x is going to infinity. So we got a big number times another really big number, and that's going to give us another big number. So the denominator is going to infinity, okay, but the numerator is staying at 1, so that means the whole fraction is going to 0. Alright, so I hope this video's helped. I'm going to do some more videos on L'Hopital's rule. Hope you'll check those out, and if they're helping, hope you'll subscribe. Alright, thanks.